Hi, Assalamualaikum warahmatullahi wabarakatuh. So today I would like to continue about the semiconductor. So one crucial or things about the semiconductor, which is energy gap. Compared to the metals, there will be no gap between the valence band and the conduction bands. So in the semiconductor as well as insulator, there will be gap here between valence band and the conduction band. So this we discuss about the gap about the gap of the semiconductor. So basically we can say that insulator, because of the wide gap between valence and conduction band, the electron here cannot move to the conduction band. So when it's happened, we can say that it's a insulator. But for semiconductor, when we feed with the photon, the electron here will move to the conduction bands, and then to create the conducting of material. So this is a part of the gap, energy gap of the band structure. This is part of the band structure. This is the energy, and this will be the momentum or the vector. So this will be the valence band maximum, where all the electron will stay here. Okay, electron here. But the conduction band minimum will be the available state that electron can move to the conduction band. So now we can go to the next part, will be the type of the band gap. It's not the type of semiconductor yet, but the type of the band gap we can divide into two, which is direct gap, and another part will be the indirect gap. The difference will be, for direct gap, you can see that the valence band maximum here is the valence band maximum, and this will be the conduction band minimum. Okay, so the valence band maximum and the conduction band minimum, okay, located at the same K space or the same momentum. So what happened when this material been hit by the photon? Okay, the photon will move here. Okay, HV. The electron will get enough energy, which is the photon energy at that time may be very near to the energy gap here. So the electron here will move to the conduction band, and it will create what we call as a electron hole pair. Electron and hole pair. Okay, why I keep using the method will be the when electron move, it will leave a empty space here we call hole. It's like when we sit in a chair and we move to another class, and then we leave an empty chair here. So that's what we call as a hole. So they will create the electron hole pair. But for the indirect gap, there will be another part, because the conduction band minimum here are not in the same K space or the momentum. So what happened when the hit by the photon? So the photon will increase, the electron will move to the conduction band, and then they need to have a what we call as a phonon energy here to change the momentum, so that the electron can move to the conduction band minimum here. So that's why this is a indirect gap. Example of the direct gap is like a gallium arsenide. That will be the example of the direct gap. But for the indirect gap, example will be the silicon. The direct gap material related to the what we call as the optical properties. Okay, something like LED, photon absorption. So what happened? Because they have what we call as a recombination, because when electron move here, it will miss their own place, so the electron will come back again to the hole here. So what happened? It will produce light called the HV. So that will be part of the type of band gap. And later we discuss about top of the semiconductor. Thank you. Assalamualaikum.